Hello everyone. So today I want to talk quickly about rotation matrix in 2 dimensions, of course. 2D rotation matrix just means that we are rotating about the z-axis, which means that we're only rotating the xy plane. As a visual, imagine that we have this as the z-axis and we have the xy plane, and all we're doing is we're rotating the z-axis. So the xy plane will rotate, but not the z-axis. So essentially, we can get rid of the z-axis, so we can represent our 2D rotation with just the x and the y. So in this case, let's say we have a vector v, which is 3 in the x direction and 2 in the y direction. And essentially, this vector v, we want to find out if we rotate it, let's say by 90 degrees, just as an example, and this new vector v prime, it will have the same magnitude because we are rotating it, we're not changing its length. But we want to know what the coordinates of this vector are. So we want to know the magnitude of its x and y direction. So to do that, we have our rotation matrix, which we can call A, and some people call R. For the z-axis rotation, this can be written as cosine of theta, negative sine of theta, 0, sine of theta, cosine of theta, 0, 0, 0, 1. If we multiply this matrix A by the vector v, we will get our new vector v prime. So let's try and do that. Okay. So we know our vector v from the previous example up here is 3 in the x direction and 2 in the y direction. So we can write this as v is 3, 2, 0, where 0 is in the z direction, it doesn't actually go there. And we rotate it by an angle theta of 90 degrees, or pi over 2 radians. So what we can do is just simply plug it into this equation here. So multiplying the matrix A by the vector v, we get cosine of theta, negative sine of theta, 0, sine of theta, cosine of theta, 0, 0, 0, 1, all multiplying 3, 2, 0. Now cosine of theta is cosine of 90 because we're rotating by 90 degrees. And sine of theta is sine of 90. And if we do this on a calculator, or maybe you memorized it, cosine of 90 is 1. Sorry, not 1, 0. And sine of 90 is 1. I had it backwards. If we do this, we will get a new matrix, which we can write cosine of 90 is 0, negative sine of 90 is negative times positive 1, sine of 90 is just 1, and cosine of 90 is 0, so we get this. And we know that v prime is equal to this. So if we solve it, we get 0 times 3 plus negative 1 times 2 plus 0 times 2. So we get 0 times 3 plus negative 1 times 2 plus 0 times 0. And then in the second column, second row, we get 1 times 3 plus 0 times 2 plus 0 times 0, and 0 times 3 plus 0 times 2 plus 1 times 0. All of the multiplied by zeros we can get rid of. So what we're essentially left with is negative 1 times 2, which gives us negative 2, 1 times 3, which gives us positive 3, and then the last row we get 0. This essentially tells us that if we have our xy axis, our first point, our first vector was 3 going in the x direction and 2 going in the y direction. And if we rotate this by 90 degrees, so we're just basically rotating it around, the new vector will have -2 as its x component and +3 as its y component. Overall, the magnitude of the vector v prime is the same as v, but the coordinates of the x component and the y component could be different when you rotate it.